Hello.
Hello, sir.
How are you, Harsh?
Fine, sir.
In doubt from last class?
No, sir.
Okay. So next we have to define about Stokes Law. It mainly depends upon three factors. First is coefficient of viscosity of liquid. Second is radius, and third is velocity of projection of object. So according to concept of dimension analysis, we may write viscous force experienced by this particular object will be K times eta raised to x r to the power y velocity to the power z. Now, write the dimension of each quantity towards left side and right side. So for force, we have ml t to the power -2, k being proportionality constant, so it will be unitless quantity. Next is eta, ml -1, t -1 raised to x. Radius is length raised to y, and velocity is Lt -1 raised to z. So on rearranging, m raised to x, L raised to -x plus y plus z, and t raised to -x minus z. Now try to compare each coefficient or each exponential towards left side and right side and try to find the value of x, y, z. Okay, Harsh?
Yes, sir.
Harsh, solve.
Sir, I got the values of the exponents.
Yes?
Sir, I got the values of the x,
Tell me
y,
the values.
and
Tell me the values.
Sir, x is 1.
Yes.
Y is 3.
Okay, and Z?
Z is also 3, sir.
You have done a little mistake. Let me solve.
Yeah.
On comparing the exponent, let's say we have m raised to x in right side and m raised to 1 in left side. So on comparing, x will be equals to 1.
Yeah.
Next, for length, we have minus x plus y plus z equals to 1. And for t, minus x minus z equals to minus 2. So take out minus common from either side. So x plus z equals to 2.
So
I have taken out minus common from both these two parts.
Okay.
So this minus and this minus cancel out.
Yeah.
Or you may take as it is, according to your choice. Now put the value of x to be 1 plus z equals to 2. So z will be equals to just 1. Is it clear?
Yes, sir.
Now put these values in this middle part, minus x plus y and plus z equals to 1. So this term and this term cancel out. So you're left with y equals to just 1.
Yeah.
Okay. Now put these values in the above expression and instead of k, just put 6 pi. So F viscous equals to 6 pi eta raised to 1, radius raised to 1, and velocity raised to 1. So this will be our final expression of viscous force experienced by this object.
Okay, sir.
Now in this part, 6 pi will be constant. Eta, coefficient of viscosity, will also be constant. And radius, this entire term will be constant from this point to this point. Only the variable part will be velocity. So we this whole constant term, we take it as B. And this particular B will responsible for damping or causing opposition to that particular object. So this B is called 6 pi eta times R, which is also called damping constant or damping factor, the factor which causes opposition to the object. Okay?
Yes, sir.
So we can write viscous force equals to B times V. And since this force is opposing nature, so it will have some negative sign with it. Any doubt?
No, sir.
Okay. Just write it down.
Yes, sir. Done, sir.
Okay. Let me give you a question related to this part. A sphere is projected at 10 meters per second through viscous liquid having damping constant (0.5 kg per second square, kg per second. Find velocity of body in 2 seconds. Let's say a sphere of mass 1 kg. Now, how to solve this particular problem? You have to calculate velocity at any instant. So let me define you. We have force, which is equals to B times V with some negative sign.
Yeah.
Is it clear?
Yes, sir.
So we may write this particular force according to second law as mass times acceleration. Is it clear?
Yes, sir.
So acceleration will be equals to minus of B divided by M times V. Is it clear?
Yes.
So this acceleration will also be written as dV over dt equals to minus of B by M times V. Is it clear?
Yes.
So just rearrange this particular expression and keep same variable to one side and rest of the term to other side. So we may write dV divided by V to one side and minus of B by M into dt to the other side. Is it clear?
Yes. Yes, sir.
So you say why we have used this particular expression instead of using equation of motion. So you must have done about uniformly accelerated motion and non-uniformly accelerated motion in chapter 3rd.
Yes.
For uniformly accelerated motion, if acceleration being constant, we use equation of motion. But if motion is non-uniformly accelerated, it means at each instant, force will be different and acceleration will be different, then we will use calculus method. Since in this part about viscous force, since force is proportional to velocity, so at each instant, velocity of particle will be different, so force will be different, and hence acceleration will be variable. Hence, we have to use calculus method. That's why I'm using this part. Is it clear?
Yes, sir.
So how to get the actual value? So just integrate this particular quantity. What will be the integration of this dV over V?
dV over.
Or simply tell me about integration of dx over x. It will be ln x. Okay.
Okay.
Ln is natural log.
Okay, sir.
So to find this part, let me define you about its limit. Initially, at time 0, body is projected with 10 meter per second. So it must have some velocity 10 meter per second. So at time t is equals to 2 seconds, we have to calculate its velocity v. Is it clear?
Yes, sir.
So 1 by v on integration, it will give you ln v limit, upper limit, lower limit equals to b, we have 0.5 divided by mass 1 kg.
1
dt on
kg.
integration will be t. Is it clear?
Yes, sir.
Now put the values. So it will have ln upper limit minus ln lower limit equals to 0.5 by 1 into time taken 2. So it will become 0.5 into 2, that will be 1, or simply minus 1 in this part. ln v over ln 10. Let me define. You must have learned about log m minus log n equals to log of m by n. You know this property?
No, sir, we didn't hear, we didn't learn this.
Okay. Do you know about log?
Logarithm?
Yeah.
No, sir. Like in school,
Okay.
didn't teach us.
Let me define you first why we have used log and how to solve these type of problem. Suppose if you have 2 to the power 3 equals to 8. Is it clear?
Yes, sir.
So 3 is called exponent and 2 is called base or radical, and 8 is any number n. Similarly, if you have any expression e to the power x is equals to n. So e is any specific number which is called exponential function, which is equals to 2.72, okay? And x is exponential of it. So if you have to somehow reverse this particular process to find x by using these two terms. So we introduce the concept of log. So it states x will be equals to log to the base e times n. Is it clear?
Yes, sir.
So what do you mean by log? So you'll say log is just a reciprocal of exponential function. Okay?
Yes, sir.
This particular log to the base e is also called ln, that is natural log times n equals to x. So it will have same property as for exponential function. Let me define you. If you have x to the power m multiplied by x to the power n, so it should be equals to x to the power m plus n.
Yeah.
So in terms of log, it will be if log m plus log n, it will be equals to log of m multiplied by n. Is it the same term? Since we have in multiplication, exponential get added. So if you have log
here in
plus
addition,
plus, get multiplied. Okay.
Okay. Yeah.
Similarly, if you have x divided by x, so exponential would get subtracted.
Yes.
So in concept of log, log m minus log n, it will be equals to?
Okay. Like m by n.
Good.
Yeah.
Log of m by n.
Yeah.
Okay.
Yeah.
Similarly, in this part, we have log v minus log 10. So what can I write in this part? V by 10.
V by 10. V by 10.
Equals to minus 1.
Yeah.
Okay. So if you have to reverse this particular process, you may write, let me define you one more thing. To get this particular value in positive way, just reverse this particular expression. It means ln 10 minus ln v, it will become positive 1.
Yes.
So ln 10 divided by v equals to just 1.
1.
Is it clear?
Yes, sir.
Now, just see this particular expression. We have x is equals to ln n. So on reversing, we may write this particular term as this.
Yes.
So if you remove this particular ln, this particular quantity will raise to some exponential function. So reverse form of this will be 10 divided by v equals to e raised to 1. Okay?
Okay. Yes. Okay.
Now e is nothing but 2.7. So v will equals to 10 by 2.72. So it will be your final answer at 2 seconds. Is it clear?
Okay, sir. Yes, sir.
I think quite complicated or too much mathematics. Okay.
It's kind of complicated.
Okay, no problem. Just write it down, the logarithmic part and its various property. Then it will become more easy for you.
Yes, sir.
Okay. Do you have maths or bio?
Sir, bio, sir. Biocomputers.
Okay, okay, okay.
Sir, can you scroll a bit down?
Down or up?
Down, sir, down. Yeah, okay. Thank you, sir. Done, sir.
Okay. For this problem, just remember only the logarithmic part and nothing more, okay?
Okay, sir.
Next is on application of this Stokes law. Let me define you about terminal velocity. Suppose if a body, this, is projected or simply dropped in a viscous medium. So through its falling, initially it will accelerate due to gravity. So on acceleration, its velocity will also increases consequently. So let's say at this particular instant, it have some velocity v, and let me define you on various forces acting on it. So it must be experiencing a viscous force in backward direction. Since it is in fluid, so it must be experiencing buoyant force due to gravity or against gravity, weight of object, and downward direction. So it must be experiencing these three different forces. Is it clear?
Yes, sir.
So if sum of all forces acting on this particular object at this instant becomes zero, so acceleration of object becomes zero, and hence velocity of object becomes constant. So this constant velocity with which body will ascend or descend in this particular viscous medium is called terminal velocity. Is it clear?
Yes, sir. Yes.
So terminal velocity is the constant velocity with which body will ascend or descend in viscous medium is called terminal velocity. So at this point, since velocity becomes constant, so acceleration will be zero and force will be zero. So we have these three different forces, two forces acting upward and one force is acting downward. So we may write viscous force plus bound force equals to weight of object. Viscous force is 6 pi eta r times velocity, and bound force is density of medium times volume of object immersed times gravity. Weight is density of object, volume of object times gravity. So just move this bound force part to right side. So you'll get 6 pi eta r times velocity terminal equals to, take 4 by 3 pi r cubed to be common. So you're left with sigma minus rho times gravity. So move these terms to right side. So terminal velocity, on simplifying it, will become 2 times r square by 9 times eta bracket sigma minus rho times gravity. So this will be our final expression of terminal velocity of object in this viscous medium. Is it clear?
Yes, sir.
But this particular expression is in terms of radius and density. Must be asked in some other form also. So let me define you in terms of mass. So you may write in terms of mass, viscous force plus bound force equals to weight. Viscous force is 6 pi eta r times velocity. Bound force is rho times volume into gravity, sigma times volume times gravity. So 6 pi eta r times terminal velocity equals to sigma volume gravity minus rho volume gravity. Take out sigma volume gravity to be common. So you're left with 1 minus rho by sigma. Now move this quantity to right side. So terminal velocity equals to sigma into volume. It will be mass of object times gravity divided by 6 pi eta times r bracket 1 minus rho by sigma. So this will be your another expression of getting terminal velocity in terms of mass of object. Is it clear?
Yes, sir.
Any doubt?
No, sir.
Okay. Just write it down.
Done, sir.
Okay. Now, related to this expression, we may define some term. First is graph. Terminal velocity is a constant velocity, so it will be till this. Let's say velocity versus height or velocity versus time. So in first part, suppose if a body is dropped in this particular viscous medium, so graph of it will be like this. It may attain terminal velocity after some time or at some height. So in this part, u is 0. Suppose if a body is projected at some initial velocity, but less than its terminal velocity, so it may follow this particular trajectory and still attain terminal velocity after some time. So in this part, u is greater than 0, but less than its terminal velocity. Suppose if a body is projected at velocity greater than its terminal velocity, so on falling down, its velocity continuously decreases and it will may further attain terminal velocity after some time or at some height. So in this, initial velocity is greater than its terminal velocity. So this is terminal velocity. So a body may attain terminal velocity depending upon its initial value related to these three different ways. Is it clear?
Yes, sir.
Now, according to this expression, we may write if sigma is greater than rho, so terminal velocity will become positive. It means body will descend in this particular viscous medium. Second, if sigma equals to rho, then terminal velocity becomes 0. It means object will no longer descend or ascend. It will remain at their own position in equilibrium. Remain at its own position. Third part, if sigma is less than rho, so terminal velocity will become negative, then object will start ascending. Is it clear?
Yes, sir.
Okay, just write it down. I'm giving an expression.
Done, sir.
Okay. Find terminal velocity of air bubble in water having radius 2 mm if eta is 0.005 Pascal second. So in this part, we have air bubble. So its density will be 1.293 kg per meter cube. Density of surrounding, that is rho, density of water, 1000 kg per meter cube. Now just compare these two values. So you'll say density of object is very small as compared to density of surrounding. So we may neglect this particular expression. So according to the above formula, velocity equals to 2 times r square by 9 times eta, bracket, sigma minus rho times gravity. Since sigma is very small as compared to rho, so we may neglect this particular expression. Okay, put
Yes,
all
sir.
the values and simplify it.
Okay.
Take the gravity to be 10.
Okay, sir.
Harsh, any problem while solving?
No, sir, no, sir.
Okay.
Sir, I got the answer, but I think it's wrong.
Why it's wrong?
It's too big.
Okay, let me solve. We have 2, radius is 2 mm.
Yeah.
So to convert it into meter, it will be 2 into 10 to the power minus 3 whole square. Divide by 9 times eta, which is 0.005. Bracket, sigma is neglected, and rho we have minus 1000 into gravity 10. So on solving, you will say 2 into square of 2, 4, and square of 10 to the power minus 3, you will 10 to the power minus 6. Negative sign, keep it outside, 10 to the power plus 3 into 10, divide by 9 into 0.005, you may write 5 into 10 to the power minus 3. Now, further, just multiply the numerator part, 2 into 4, 8, into 10, that is 80. 10 to the power minus 6, 10 to the power plus 3, and this 10 to the power minus 3 on moving to numerator, it will become 10 to the power plus 3. 9 into 5, 45. And so this part, and this part will cancel out. So you're left with 80 by 45, or simplify it, 5 into 16 and 5 into 9. So 16 by 9, 9 in one time, 7077 meter per second. Is it clear?
Yes, sir.
Where you have done mistake?
I got 177.77.
Okay.
Because
it means
I didn't convert millimeter into meter. That's it.
Okay.
Done, sir.
Okay. Now, related to this part, you'll be asked to calculate in terms of combination of drop. So let's say we have some number of drop, or simply raindrop, which was initially falling with some terminal velocity, let's say V1. If they combine together to form single large drop, so you'll be asked what will be its new terminal velocity on combine. Let's say V2. So what will be the relation between V1 and V2? During this particular combination, we can say volume of initial should be equals to volume of final. Initial volume, that is 4 by 3 pi r cube, and we have n number of drops, must equals to 4 by 3 pi r cube. So 4 by 3 pi will cancel out.
Yeah.
So you'll get r equals
R
to
cube. Yeah.
During this conversion from single drop to form single large drop, there is change only in the radius of that particular object. The rest of the quantity is constant. Since according to the formula for terminal velocity, 2 times r square by 9 times eta, sigma minus rho times gravity. Gravity will be constant. Sigma and rho will be constant, and eta will also be constant. So only depending factor will be radius. So we can say V1 divided by V2 must equals to R1 divided by R2 whole square. So put the value of R1 to be small r initially and R2 to be capital R, which is equals to n to the power 1/3 times R whole square. So R and R will cancel out. So you're left with n to the power 2 by 3. So on cross multiplication, you will get V2 equals to n to the power 2/3 times V1. So this will be your final expression of getting terminal velocity for combination of drop. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
If 8 raindrop falling with combined together, find new terminal velocity. Just use the above formula and try to find. Initially, raindrops are falling with 2 mm velocity. Now, what will be its new velocity if they combine to form single last drop? Okay.
Yes, sir.
Any problem while solving, Harsh?
No, sir. Just using the formula, right? That's it.
Yeah.
Okay. Sir?
Yes.
We have to convert millimeter into meter per second, right?
No, you can write as it is mm per second.
That's it. So here n is the number of droplets, right?
Yeah.
So it means 8 2/3.
Yeah.
Into 2.
Yeah.
That's 10 2/3. That's it, right?
So you must have to solve that particular exponential part. That is 8 raised to 2/3. How to simplify it?
So that's what I'm thinking, sir. I forgot.
Okay. Just break this 8 in terms of 2. So you may write 8 as 2 to the power 3 and whole to the power 2/3.
Yeah.
Now, power to the power get multiplied.
Multiplied,
so it
yeah.
will become this and this will cancel out. So you're left with
2 raised to 2, 4.
Good. So V2 will be equals to n raised to 2/3 times V1. And we have 8 to the power 2/3 times V1, that is 2.
Into 2.
So it will be 4 into 2, that will be 8 mm per second.
Yeah, 8 mm per second. Yes, sir.
Any doubt?
No, sir. It does.
Okay.
Easy.
Done?
Yes, sir. Done.
Okay. Next is equation of continuity. Suppose you have any tube having area of cross section A1 and A2. So at this instant, velocity of liquid will be V1. At this instant, velocity of liquid will be V2. And since each layer having same velocity, so you'll say liquid will be non-viscous, incompressible. So we have to relate between A and B related to this expression for any instant. So let me define you how to solve. Consider non-viscous, incompressible liquid is flowing in a tube of variable cross section. So first, mass of liquid entering per unit time. So mass is equals to density into volume. So we may write density into volume. So volume is area of cross section into length per unit time. So divide by T. Is it clear?
Yes, sir.
Now this particular quantity, X per unit time, is also termed as velocity. So it will be rho A V1. Similarly, we may write mass of liquid ejecting per unit time. So it will be equals to rho A V. Now, according to conservation of matter, total amount of liquid entering from one end must be equals to total amount of liquid ejecting out from the other end, we can say. Is it clear?
Yes, sir.
So using conservation of matter, mass of liquid entering per unit time must equals to mass of liquid ejecting per unit time. So on putting the values of these two parts, you will get rho AV must equals to rho AV. Rho and rho gets cancelled out. So A1V1 equals to A2V2. I defined your previous part in Reynolds number, area of cross section multiplied by its velocity is also called Q. So we can say Q equals to area of cross section into velocity, that is rate of flow of liquid will be constant. So if you plot graph in between these two parts, that is for area of cross section versus velocity. So we'll say since these two quantities are inversely proportional to one another, since product of these two terms is constant, so graph will be rectangular hyperbola like this. Is it clear?
Yes, sir.
If one increases, the other one decreases. If one decreases, the other must be increases, so that product of these two quantity will be constant at any instant. Just write it down.
Done, sir.
Okay. Now, related to this part, let me give you a question. If liquid in this particular arm is flowing at 5 meter per second, area of cross section A, and this arm flowing at 3 meter per second, area of cross section is A. Now this particular having 20 holes, each having area A by 5. So you'll be asked, find velocity of ejecting liquid. Let me define you how to simplify it. First, just check through how many different arms the liquid is entering in this particular tube. So you will say through this part and through this part, and there is only one segment through which liquid is ejecting out. So we can say, according to conservation of matter, total amount of liquid entering must equals to total amount of liquid ejecting. So it will be equals to A1V1 plus A2V2 must equals to A3V3. But in right hand side, we have number of holes. So it must be n number of holes times A3V3. Is it clear?
Yes, sir.
Now put all the values and simplify it to find V3.
Okay.
Harsh, any problem?
Sir, I solved both the sides, but I'm getting like 40A is equal to 20A.
So A and A will cancel out? No.
Yeah.
You
But
have to
how is it
calculate.
possible?
No, just 1 minute. In left hand side, we have A1 as A multiplied by V1, that is 5.
5 plus
A2, A multiplied by V2, 3 equals to number of holes, 20 multiplied by A by 5.
A by 5 into V3.
V3.
Yeah.
So just solve this left hand side part.
This is
5A plus 3.
8A
8A equals to this term and this term will cancel out in 4 times.
Yeah.
So you're left with 4 times of A into V3.
Yes.
So move this particular term to left side. So V3 equals to 8 times A divided by 4 times of A. That will be 2 meters per second.
Got the same answer, like 40 and 20. And then
So
I
40 divided by 20 will be
20.
2.
Yeah, 2.
Good.
That's it. Yeah, same answer, sir.
Okay. Now, related to this part, there will be a question, conceptual question. You must have experienced, suppose there is a tap. When you open this particular tap, so structure of liquid ejecting from it must be like this. Like this. So you'll be asked why width of stream on falling down decreases. Any idea? You might have experienced this in your day-to-day life.
No idea, sir.
Okay, just let me give you some hint related to this part. Just suppose this particular point to be a reference. Okay. Now just consider any cross-sectional area, this part, any cross-sectional area, this part, and so on. So on falling from this point to this point, and on falling from this point to this point, which having more height covered, the upper one or the lower one?
So the lower one.
Good. And while falling down under the gravity, you must have used V equals to simply root under 2 times of h.
Yes.
So we can say on falling down, height increases. So consequently, velocity also increases. Is it clear?
Yes, sir.
And since according to equation, rate of flow to be constant for this particular stream, so A and velocity must be inversely proportional to each other. So if velocity increases, area must decreases. Hence, width of stream on falling down decreases.
Okay.
Is it
due to
clear?
velocity? Okay.
Yeah.
Okay.
So you'll say on falling, height increases, so velocity increases. Consequently, area decreases since area times velocity will be constant. Therefore, on falling down, width of stream decreases. Harsh, is it clear?
Yes, sir. Yes.
Okay. Harsh,
Done,
Dash?
sir. Yes, sir.
Okay.
Yes, sir.
Next is the most important part of this particular chapter is Bernoulli's principle.
So this is the last part?
No, there is various application of Bernoulli's principle. Yeah, it will be the last part of this chapter.
Okay, sir. No, sir, because there was something due to detergents and something it's written in the book.
It was surface tension.
Yeah, surface tension and capillary rise and then detergents and surface tension. Yeah.
I defined it in the earlier part.
Yeah.
I break the whole part into two categories, the static part and in which I had defined you surface tension.
Yeah.
The whole different process related to surface tension, that is
Yes.
capillary rise, ascent formula, descent formula,
Okay.
or types of
Yeah.
meniscus, and various application of surface tension, that is how it will depend upon change in temperature, its spreading out tendency,
Yes, sir.
how it will behave on adding detergent to it, or adding impurity in liquid. That was all included in surface tension at its various application.
Okay, sir. Yes, sir.
So Bernoulli's principle. Suppose you have any tube like this. So by taking this particular level to be reference point, let's say this is having area A1, A2, in which non-viscous incompressible liquid is flowing. So at this instant, velocity of liquid will be V1. And velocity of liquid at this instant, V2. Now, this particular tube or this particular cross section is at height H1 from this reference point, and this having height H2. So we have to define the flow of liquid in this particular tube. Will it be necessary, or it will be or we must require some external agency to this particular flow from some lower height to some higher term? So for this purpose, we must require some pressure difference from outside. So let's say P1 is at this point and P2 is at this point. Is it clear?
Yes, sir.
So this pressure difference between two ends will be responsible for the flow of liquid throughout in this particular tube from some lower end to some higher end, having varying cross-section area. So let me define you about this Bernoulli's principle. State the sum of pressure, kinetic energy per unit volume, and potential energy per unit volume at any instant for the flow of non-viscous incompressible liquid will be constant. So it states for non-viscous incompressible liquid in a tube, the sum of pressure, kinetic energy per unit volume, potential energy per unit volume at any instant will be constant. Is it clear?
Yes, sir.
So you may write these particular terms to be limitation of this Bernoulli's principle. So you may be asked, what would be the limitation or essential condition for this particular principle? So first is liquid should be non-viscous. It should be incompressible. There will be no change in gravity throughout. It means gravity will be constant, and hence energy should be conserved. Any doubt?
No, sir.
Okay, just write it down till this part first.
Done, sir.
So first part, work done due to pressure difference. Work done is simply force times displacement. We may write force in terms of pressure as net pressure into area of cross-section times displacement. Area of cross-section times displacement is also called volume. So it will be P1 minus P2 times volume. Is it clear, Harsh?
Yes, sir.
Okay. Now, just tell me about work energy theorem you must have learned in chapter 6. Do you know?
The work energy theorem,
Yeah.
like the definition or
Definition or formula, if you know.
definition.
What it simply states. Yes. Work done by any external agency or work done by any non-conservative force must equals to change in kinetic energy and change in potential energy.
Potential energy.
Okay.
Yes. Yes.
So we can say work done by any external agency will be equals to sum of change in kinetic energy and
plus sum of P, potential energy.
Now in this part, work is done by external agency in terms of pressure. So it will be P1 minus P2 multiplied by volume. Change in kinetic energy, we have half m V2 square minus V1 square. Change in potential energy, we have mg H2 minus H1.
H1.
Now move this volume part to right side. So you'll get P1 minus P2 equals to half m divided by volume. Okay. V2 square minus V1 square.
V1 square
plus m divided by volume, gravity, times H2 minus H1. Is it clear?
Yes, sir.
Now, this particular quantity, that is mass by volume is also called density. So we may write half times density V2 square minus
V1
half rho V1 square rho g H2 minus rho g H1. Now move the quantity which having same subscript to one side. So it will be P1 plus half rho V1 square plus rho g H1 must equals to P2 plus half rho V2 square plus rho g H2. Yes. So we have same quantity in both sides, but only there is difference in their subscript part. So we can write, therefore, P plus half rho V square plus rho GH at any instant for the flow of this particular liquid is constant. Is it clear?
Yes, sir.
So first term in this expression, we have pressure. Second term is kinetic energy divided by volume. And third term is potential energy divided by
volume.
Okay. Now in this expression, rho and gravity will be constant. Rho is density of liquid and g is gravity. Only these two terms will be constant. Rest will be variable. So we may write this particular expression as P divided by rho times gravity plus V square by 2 times of gravity plus H. Again, it will become constant. I'll just divide the whole segment by the constant part in this particular expression, okay? So this particular quantity, this quantity and this quantity, this first one is called pressure head. The second one related to velocity is called velocity head. And third one is called gravity or gravitational head. So related to this part, you'll be directly asked, calculate velocity head related to this particular expression. So what do you mean by velocity head? So you'll say half of v squared by gravity. Okay?
Yes, sir.
Just write it down to this. Any doubt?
No, sir.
Okay.
I can scroll down. Done, sir.
Okay. Now, related to this Bernoulli's principle, let me define you its various application. First is Magnus Effect. Suppose you have any spherical object. If it is thrown without spinning, so it may follow this particular trajectory and hit the ground at this particular point, like this. Now, what will happen if you throw this particular object while clockwise is spinning, let's say along this way, will there be any change in its trajectory, or it will remain follow its own trajectory?
Sir, while it's spinning, it will
Okay, let me
change,
define
sir.
you.
It will change.
Okay. Why there will be change?
So because it's spinning and due to
Okay,
how do
let
I
me
explain
define
this?
it.
How do I explain this?
Suppose this is spinning in clockwise direction. So air at this point must be moving along this way or
Yeah,
opposite of this.
Yeah, resisting this, yeah.
And the same velocity of air will be along this for this bottom part. Now, on comparing, you will say at the uppermost particle, since both velocities in opposite direction, so net velocity will get decreased. And for bottom part, since both are moving along same direction, so net velocity will increase. Is it clear?
Yes, sir.
According to Bernoulli's principle, P plus half times rho V square plus rho GH is equals to constant. So this particular term is height, or we are just assuming height, or there is no much difference in height. So just neglect it. So we're left with these two parts. So if velocity increases, pressure must decreases, and velocity decreases, pressure must increases, so that sum of these two terms at any instant will be constant. Is it clear?
Yes, sir.
So in the uppermost part, since velocity is decreasing, so pressure must increase, and the lower part, velocity is increasing, so pressure must get decreased.
Must decrease. Yes.
Okay.
Yes, sir.
Now these two pressure difference, we have some larger pressure at the upper end and lower pressure at the bottom end. This will create some pressure difference, and due to which we have higher pressure in the upper part and lower pressure in lower part. So matter will move from higher pressure to lower pressure. So due to this, it will tend to go along this way and may hit ground at this particular instant. Is it clear?
Yes, sir.
So this particular trajectory of ball will be in terms of clockwise rotation. Similarly, you will be asked what will happen if you throw this particular ball in anti-clockwise spinning. So it may follow this particular trajectory and hit the ground at this instant. So it will be in anti-clockwise. And the middle one for no spinning. Is it clear?
Yes, sir.
Just write it down. You must observe this particular relation as well. Suppose, take this particular ball, and if you are at some great height or at any heel, and if you throw this particular ball in anti-clockwise spinning, like this, so this ball will tend to move along this way, as if it is rolling on air and move away from you, like this.
Yes, sir.
That will be based on Magnus Effect or Bernoulli's principle. Is that clear?
Yes, sir.
Okay.
Done, sir.
Okay. The next related application will be, you'll be asked, suppose you have any paper, enfold inward like this. So if you blow air over it like this, in which direction does the tilted part will bend? Towards downward or upward?
Which direction the lower part will
Suppose
bend?
this is your paper. Okay.
Yeah.
I have enfold inward like this.
Yeah.
And suppose if you blow air over it.
Yes,
okay?
sir. Yeah.
So in which direction do you think this will bend? Towards upward or towards downward?
Downward, sir.
Downward? No. Let me show you. Suppose if you blow air in upward direction. So in the upper part, velocity will increase. So what will be its impact on pressure?
The pressure decreases.
Good. So pressure decreases. In lower segment, since there is no change in velocity, so there will be no change in pressure. So it will remain same as initial part.
Okay.
Due to decrease in pressure in the upper part, the lower pressure gets higher as compared to the uppermost part. So this pressure difference will tend to uplift this particular paper to upward direction.
Oh, okay.
Okay, any doubt?
Yes. No, sir.
Similarly, there will be a question. Suppose there is a hut and we have to calculate in a storm. Suppose air and outside may go along this way, this way, this way. So velocity outside will increases and consequently pressure decreases. So inside there is no movement of air. So you can say pressure will be zero, velocity will be zero.
So there is no pressure.
Pressure will be due to air inside, that will be atmospheric pressure. So it will be just P naught. Okay.
Okay.
So what should be the velocity of air above to that particular roof that will be capable of uplifting the entire segment? So let me define you according to Bernoulli's principle. Let's say this is first and this is second. So according to Bernoulli's principle, since there is no much difference in height, so we may neglect that particular component. So we may write P2 plus half rho V2 square equals to P1 plus half rho V1 square. Is it clear?
Yes, sir.
V1 we have 0, so it will become 0. So move this quantity half rho V square, that is pressure outside, equals to P1 minus P2.
Okay.
This pressure difference will be enough to withhold or uplift the entire part. So pressure will be equals to force per unit area. So force will be mg divided by area of cross section of rho A. It will be equals to half times of rho v2 square. So velocity will be equals to 2 times of m into g divided by rho times of A root under. So this will be velocity of storm for which to uplift this entire roof. Is it clear?
Yes, sir.
Similarly, you may define for upliftment of aeroplane. Okay?
Yes, sir.
Just write it down.
Yes, sir. Done, sir.
Okay, any doubt?
No, sir.
Okay, let's stop here for today. Okay, I've just left you one more part, that is Torricelli law. Okay,
Okay.
and its various other form. In next class, we'll start with Torricelli law, and then after completing it, we'll start new chapter, Thumb Properties of Matter. Okay.
Okay.